Okay, so we have a MacBook Pro. It's A1278. The description is no backlight. It has been to a previous repair work. It's been to a previous workshop. And the screen connector has also been replaced. If you see this, screen connector has been replaced. So we're not sure exactly the state of the no backlight. So here we have the schematic open, and this is, let's open the board view. So the board view, it's the board number is 820-3115. That is the board view. So that's the board number. We have identified that yes, indeed, the machine power is on. There's been a pre-assessment, machine power is on, but the issue, it's no backlight. And that's expected because we can see some work being done here. As you can see, the machine power is on, but the issue we want to tackle, it's a no backlight. Now, so first thing we want to do is we want to check for screen detection, because when it comes to backlights, there are three stages you should be looking out for. The first stage is screen detection, for the screen to be detected. That is the first thing. So when we click on, let's click on the screen connector. This is the screen connector here. This is the information of the screen connector. So on the signals, usually when you in every section there are key signals that you can deem critical, or that you can deem very important. So there are three stages that need to be fulfilled when you are when you're talking about backlight. The first stage is the screen has to be detected. If the screen is not detected, definitely backlight is going to be on the last phase. The screen needs to be detected before there will be a build up to the machine generating backlight. The second phase you want to look out for is you want to find out if you have image, because if you do not have, now the concept of if you have image, it's sometimes you will sometimes you power on the machine and then there will be a reaction on the screen, but there is no image, so to say. You cannot see image. So you want to look out for image. You want to be sure that you have image on your display. And then the last thing, then you can now go on to checking out the backlight status. If you don't have, if your screen is not detected, if you don't have, obviously, if you don't have image on your screen, don't worry about backlight, because backlight is going to, it's something, backlight is a phase that will come at the completion of the three stages, which is your screen being detected, you have an image, and eventually now you have backlight. So what we want to do, first thing first, is to be sure that our screen is detected. If your screen isn't detected, then there will be it's a complete waste of time. Now, whenever any repair needs to be done, the first thing you want to do is you want to have an understanding of exactly where are you, which is what stage or what state is the board in, because that's the only way you know how to proceed, or the next line of action to take. If you cannot define the current state of the board, then you will only be basically uh, you only be involved in I see, I do. I mean, you see something, you do something, but there will be no logical reason behind why you do what you do. So what we want to do first is we want to define where we are by we want to connect to the screen, and then see if we at least have image, if we have, if the screen is detected. So let's do that. Let's connect our charger. Okay, and then before I connect the charger, so this is a MagSafe one, and we will have a separate videos. Like I said, I've got a couple of videos that are coming up that will be solely for beginners. Now, this is a MagSafe one, and MagSafe ones were discontinued in 2012. So MagSafe ones, the last devices that MagSafe ones were officially used for were the A1278 2012 and the A1286, the 15 inches 2012 as well. So one of the ways, so just a quick one on MagSafe ones. There are two ways you can, there are other ways, but there are two main ways you can define between a generic charger and an Apple charger. So, and also we will have an in-depth video to go over the charger and charger communication and all of the interesting thing about Apple chargers. But for today's video, just a quick one. So on your MagSafe one, one of the ways you can define a generic charger versus an Apple charger is when you connect your charger. If it's an original charger, when you connect your charger to your device, you will get a slight delay. Now that basically that it's a form of authentication that will take place. Now you will get a slight delay before the charger engages your device. So when you connect, you get a very there'll be a split second delay before your charger engages your device. So what I'm trying to say is now when you look at your charger, there is an LED here, there is a light here. Now when you connect, say for example, I'm just going to show you guys what I'm talking about. So this is my charger, and then this is my DC jack. Obviously, this is the board. So what I want to do now is I want to connect. Now, this is an Apple original charger. So the way this is supposed to behave is this. When you connect, when I connect this, and as you know, it's magnetic. When I connect this to the DC in board, what's going to happen is there'll be a slight delay before the LED comes up. However, if this was a generic charger, immediately when I connect it, there will be no authentication whatsoever that takes place in terms of any safety measures. Once I connect, if it's a generic charger, a non-Apple Apple charger, immediately you will get, once the connection is established, you immediately get the LED on. But that is not the case if it is an Apple charger. If it's an Apple charger, when you connect it, you will get a form of authentication, a form of verification, which takes a split second before the LED comes on. Now, because this is a MagSafe one, there are two behaviors in terms of the LED. Now, there are two LED behaviors on your MagSafe one. You have the green, and then you have the amber, and then eventually you have the green. So basically, there'll be three phases to your MagSafe one charger. Now, I'm just going to quickly explain what those are. And when we talk about the MagSafe 2, we can also then put them across one another side by side, and then do a broad difference between both. So the three phases of your LED would be the first, when you connect your charger to your device. So you will get it to be you will get a green you get a green LED on your charger. Now, if the charger starts to charge your device, then the green will turn into amber. That is another phase. Now, when the machine is fully charged, the charger will now move from amber back to green. So I'm just going to take that again. Now, when you connect your charger, it remains green. And then when it starts to charge your device, it goes into amber. Now, powering your device is not the same as charging your device. So when it starts to charge your device, which means when it starts to charge the connected battery, then it moves from green into amber. Now, when the battery is fully charged, then it moves from amber into green again. Now, when your battery is not connected as well, the charger will remain green. So the two times when your charger will be green, number one will be the time when it's not charging your battery, and then number two will be the time when your battery is fully charged. So those are the two reportings you will get from the charger in terms of what the green will mean. So the first green, obviously, battery is not charging. Now, at a broader level, this can also tell you when you have an issue with your charging circuitry. But that's going to be a different video all entirely. That's something different. But just to explain the difference in the LED behaviors. So when you connect your charger, the first thing you will get, obviously, you get it to be green. Now, green, that tells you that your charger has engaged your machine. Now, when your charger starts to charge the battery, then what happens is the LED will turn to amber. Now, when the battery is fully charged, the charger will now go back to green. I don't know if that's clear. Any question? So whenever you see that, now about a generic and a non-generic charger, like I said, so if it's a generic charger, When you connect the charger to the device, it's going to give you a direct engage. There's going to be a direct engagement, immediate engagement. You connect the charger, you get your LED immediately. But if it's an original Apple charger, when you connect the charger, there will be a slight delay of authentication, just a small a split second delay before the LED comes on, which is why it's always recommended to use an original charger, especially for your repairs, an original charger. And also another thing I want to quickly say is chargers they come they have machines the Macs they have so they have ratings. So for example, your 13 inches they will be rated 16.5, which is 65 watts, and then your 15 inches will be rated 18.5, which is your 85 watts. So it's always ideal when you have a bigger charger. For example, if you're using an 85 watts MagSafe one for a 13 inches, which is rated to be 65 watts, now, there will be no deficiency whatsoever, and there will be no downside to it. You will be at lock by using an 85 watts to charge a 13 inches, which is 65 watts. Now, when you go at the back of your machine, but when you look at the back of your machine, let's see, do you have and see if you have any. Okay, let me have the MacBook Air. MacBook Air. I'm just gonna show you. No, you can close it. You can close it. So if you look at this device here, so it says designed by Apple in California, assembled in China, but that's not what why here. So the model number is A46s. Now EMC is also a form of identification. Now the rate you see it's rated 14.5, so 14.8 volts. So basically, so this is the rate now. Now the charger for this machine is going to be 45 watts. However, you still can use 65 watts or 85 watts, and then there will be no disadvantage or downside to using a bigger charger to charge a lower rated device. So that's just basically on that. So yeah, now we can move on. No question, yeah? Okay. So what I was trying to describe, so this charger, it's an Apple original charger. So what we want to do is we want to now the last thing, whenever you're measuring your PPDC in, the can I have a charger? Any charger? Can I have any charger that side? So now with this charger, for example, we see what we get here. So this is 87 watts. Okay. And so our output from this charger also we say we have various output settings. We have 20.2 volt, we have 9 volt, and then we also have 5 volt. So these are the various output settings for this charger. So whenever you are obviously your charger, your PPDC in will obviously be what you have at the output of your charger. So when you're measuring for PPDC in, the output of your charger is what you will find at your PPDC in voltage line. So now let's just basically demonstrate what we were trying to say about an original charger. So when I connect the charger, make sure it's properly aligned. I connect the charger. Now, yes, like yeah. So now, I don't know if you guys caught that, but then if this was a generic charger, immediately it makes contact. Just that contact immediately, I will get my green. But because it's an Apple original charger, so when I connect, there'll be a slight delay before the green comes up. So that's just that. So what we want to do now is we want to confirm that our screen is detected, and then we can continue from there. Peter, why are you struggling? What's up? Why are you struggling now? What's up?
I'm trying to get everything.
Okay. So So now what you want to do is and I mean obviously whenever you troubleshooting like this with your board out and you have a separate screen, you always want to make sure that there is no power in your board before you make any form of connection to avoid any form of damage. So now we want to see if we have at least a screen detection. Let's see if we have that. Can you see it? Okay, there was a reaction on the screen. I'm just gonna let me disconnect. Apple logo. No, that definitely you can't see Apple logo because so with this board now, Apple logo will come from a boot drive, but there's no boot drive attached to it, so there's no Apple logo here. So what I now for older devices, you can to confirm if you have image, you can easily shine a light through the back to see if you can get image. That's for older devices. That design was stopped in 2015 from 20 that's for MacBook Pros. The MacBook Pros, that design was discontinued in 2015, but for MacBook Air the design carried up until 2017, and then from 2018 they adopted the same designs change in MacBook Pros that were implemented in 20 from 2016. So the MacBook Airs basically they got a the MacBook Air, they had a delay in redesign up until 2017. The 11 inches MacBook Air was discontinued in 2015. The MacBook Air 2017 was the last one they had before the redesign of 2018. The MacBook Pro, they had a redesign from 2016. The last one they made was the 2015 13 inches as well as the 15 inches. And 2015 also was when they first introduced the MacBook, which is the 12 inches. That's also redesigned because Apple had the MacBook before that was discontinued, and then the redesign was done in 2015. So the MacBook 12 inches is just three lines of it were made. So 2015, 2016, and 2017, and also that was discontinued in 2017, and Apple did not revisit the MacBook lines. So I'm just going to disconnect. I'm just going to disconnect. Let's see if we have a flashing folder. That's it. I don't know if you guys can see it. That is a flashing folder. Can you see it? Okay. I'm not sure if it's captured. Yeah, is it captured? No. Okay, let's try to move it just a little bit. Even then, even then. No, 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 it's fine. So, okay, see if you can get a light at the back of the display. Get it. See if you can get a light at the back of the display. Maybe it can be seen. No, at the back. Peter, I said back. Why are you putting it from the you? So that's it. But Peter, when I was saying something, so Peter, you have to understand. So Peter, this is what you need to understand. So while this is going on, you can ask me questions. You're just smiling. But when you're watching the videos, you will not. And the thing is, when I just move on, I will assume you understand. Don't say yeah. Something very small now, and then you're putting the lights. No, man, I didn't say that. If you don't understand, you ask questions. I don't see why you just watch and you don't get what I'm saying and you're not saying anything. So now coming back here, so I'm just gonna now as a technician, when you are doing your work, you need to know when to move on. So we talked about screen detection because we saw image. What does it mean? It means our screen is what? Is detected. No, not working. Screen is detected. I don't know if you understand. The screen is detected. Now, we will not worry about. So now what we if you look at the signals here, Peter, at the signal, is this captured on the screen? Yeah. Okay. Now the first pin 1 says what? GND. Yeah, that's ground. Okay. Pin 2 says what? Underscore. Can you see it, Peter? I can move it forward. Okay. Now on this line we should expect to have 3.3 volt. Correct? Now on this line also we should also expect to have 3.3 volt. Now you will see there's a difference between the first 2 and 3. Now 2 and 3, it's going to be the same, correct? So pin 2 and 3 is going to be tied together. Do you understand why? Because 2 and 3, PP3 V3 underscore LCD VDD underscore switch underscore. So and the second one, any difference? No. So which means 2 and 3 will be tied together. Now 4 will be separated from 2 and 3, correct? Now, you see 4 has a separate, you have PP3V3 underscore SO underscore LCD. Now, whenever you see SO, it simply means that SO defines the state when this rail will be present. PP3V3 underscore SO, it means that this rail will only be present when the device is in SO state, meaning when it is on. So SO means on. Do you understand? So if you measure when the device is not on, do not expect to. Now SO can also be can also be seen to mean whenever you see G3H, G3H, which is hot, means that rail is present at all times. Meaning when once your charger is connected or once any form of power is introduced into that board, that rail will be present at all times. I don't know if you guys understand. Peter, do you understand? Now, unconnected simply means that pin is not used. Unconnected, it's not used. Now this is your data line, LVDS underscore DDC. That's your data line for clock. That's the data line for data. And then LVDS IG, it's embedded graphics, integrated graphics. That is your IG, integrated graphics. So that's your integrated graphics, integrated graphics B. Those are very important. Now that is LVDS. Also, N and P. These are very important. This is the same thing. This is the same thing. Now this and this, those are also very important to rail. Now all of this from this point to that point. Now we are only dealing with image and screen detection. Image and screen detection. From that point to this point, we're dealing with image and screen detection. Now, if we move, okay, now from here now PPV out underscore switch underscore LCD backlight sounds familiar. So that is the output of your backlight. Now, what we want to confirm, so we will head to the schematic to find out what are we expected to have here. Now, just down there, you have what we refer to as LED return. You have now on your LED return, you have 1, 2, 3, 4, 5, 6 lines. Now, your LED returns, they do amazing work. Say for example, sometimes you may have your screen not properly or evenly distributed. You have a screen, you have backlight, but there is no proper distribution of the backlight. You have stage light effect where you have like dark side, or you don't have a properly lit display, even though the backlight is going to be present. Now LED, okay, so we will have a separate class on LED return. Or actually, not just that, we will have a separate class on backlight itself. So that way we can explain all of what you require before you can, or all of what you need to look out for to have backlight. But then when it comes to LED return now, so that is not going to be your primary concern. So you need to first of all have been able to pass your bridge of having backlight before you can worry about LED return in a bit of a sense. But there is more also to that in terms of how the LED returns it's crucial to the overall function of the machine. Function of the backlight circuitry. Now, all of the LED returns, for example, LED returns now, this is not something you worry about. The first thing first you need to worry about is to make sure all of these signals, you need to make sure that the screen is detected, you have image, before you can worry about our backlight. So now backlight, you have PPV out underscore switch underscore LCD backlight. So that is where our backlight is going to be. Now, When it comes to backlight, first thing first, let us determine what is the state of our backlight, the state of our backlight board, and then we can move on from there. But just some of the key things you need to know about your backlight. So your PP bus, say for example, if this is a MacBook Pro, okay, let's actually measure and then we can explain as we. So now let's check what we have on our PP bus, on our PPV out. Let's see what we have on our backlight output. So we switch our multimeter to voltage mode, and then we basically using 200 volt because our backlight, it's rated for this machine, it's above 20 volt. So definitely we will, once it has the boost, the boost has taken place, it's going to be higher than 20 volts. So now we then have to switch our multimeter to 200 volt. So usually, if this probe are going to measure something higher, a value that is higher than 20 volt, when you introduce the probe to a value higher than 20 volt, you get OL. Yeah, but that is only in your voltage mode. So if you are measuring a value that is higher than 20 volt, and then you set your knob to 20 volt, and then you measure, what you will get is OL. That is also the same reason why when you're measuring PPDC in on USB-C devices, and then you connect your charger, USB-C charger, when you get when you set it to 20 volt, when you measure, you get OL because it's exceeded what the value is set to. So now, because we're measuring for backlight, let's go to, so let's do this. So I'll just set this aside. Now we want to go to our schematic, and then we want to type it. Now to go to this section of our schematic, we need to know the name of it, which is J9000. Now we go to our schematic, and then we type what? J9000. So let's search J9000, enter. Now this is J9000. Now this is J9000. This is our what? What does it say? LVDS? LVDS what? Connector. So that is the screen connector that we're dealing with. Now, if you look at, okay, so now if our screen was not detected, then we will be worrying about this section, U9000, or worry about this. So both filters, obviously, this inductor here. So our 3.3 volt that is present, our 3.3 here. You see what now? Also, you will get the voltage what you're supposed to get. Yeah, 3.3 volt. Now this one also, this is 3.3. What this says SO. Now, which simply means, and then this obviously you have this resistor be tied to this those data lines. Let's just move past this.
SO, you said, what does that mean again?
On. Yeah, SO state is that tells you that the device is on. So that is the voltage you get when it's on. So here it says 3.3 volts. So that it simply tells you that you need 3.3 volt on this line. Now, if you go further, it says voltage is 3.3 volt. Now we have voltage. We have image. The screen is detected, so we're not worrying about this line. Now we're also not worrying about these lines for now. What we want to worry about is the backlight, which is this one. So it's PPV SO. Now our backlight, what we want to do now, it's so pin 21 and pin 22 is the line for our backlight. Now C9020, that is a cap that is tied to our backlight. So we want to now, so what we want to do, if we check here, we have 76 and 6. Now let's see what page is this. So what page are we? 74 of 86. Now we have here 76, 6 and 6. So it tells us that PPV out switch LCD backlight is also mentioned in page 77 and page 6. That's why you have this and that. So now if you want to find out where this voltage is coming from, what you do is you double tap on this. double tap, you copy it, and then you paste it here to search for where it's coming from. You want to see where this is being originated, where it's being generated from. You understand? Now, if you look at this now, this signal is going here, but you don't see where it's coming from, correct? So now let's see 9020. First thing first, let's see what we have on our C9020. Now, a very simple thing we want to do, which almost every time it's never the problem, especially if it has been to a repair shop. Almost every time it's never the problem, which is the fuse. So let's see what we have on our fuse. And also, we will also talk about in another video. Not in another video, we'll talk about if you have an issue with your fuse. Say, for example, okay, let's just quickly talk about it since we are there. So if you get a device and the fuse is blown, you get a device, the fuse is blown, the backlight fuse is blown. Definitely, when the backlight fuse is blown, there will be no backlight. Yeah. Now, before you replace your fuse, make sure you check for a short on the other side, because you want to confirm why the fuse blew in the first place. You just don't want to replace the fuse and then you get the same, because before you replace the fuse, say for example, especially when it comes to your screen cables, sometimes you might have your screen cables that are partially damaged, and as a result, they might partially be making connection to ground. So when you connect your screen, when you connect that screen cable to your board, it may create a reverse, obviously, which would then cause your fuse to blow out. Now, it is actually that fuse is actually doing you a favor, because it's a safety measure that is put in place before you replace, or before you sometimes people might not find a fuse and then they decide to use a wire. Now, if you choose to use a wire in place of your fuse, make sure you use a wire that is tiny enough to serve the same purpose as a fuse, because that line is supposed to actually break whenever there is whenever it senses any form of let's say over voltage, for example. Now, or when it's higher, or when it senses some kind of potential damage on the circuitry, the fuse is supposed to cut out to prevent further damage. So if you are to use a wire in place of your fuse, make sure the wire you're using is very tiny enough to basically break to do the same work as your fuse whenever the same threat occurs in your circuitry. So before you replace your fuse, make sure you check for short on the side to be sure that when the fuse is put back, you do not have you do not create additional damage beyond the fuse. So we just want to see what we have on our fuse. We set our voltage at our multimeter to voltage mode. We're still on 20 volt. We're not moving beyond 20 volt yet. When we start to measure our PPV out backlight, we will obviously switch that to 200 volts. So now let's see what we have on our fuse. I'm just going to switch real quick to our board view. Let's go to our board view. So now this is our fuse. F9700 is our fuse. Now you see our fuse says PP bus, pin 1 says PP bus underscore G3H, the pin 2 says PP bus underscore G3 SO underscore STD backlight underscore fused. Now we want to measure this. So you, on one side, on pin 1, you should have your PP bus voltage, and then on pin 2 you should have, this is where it feeds your backlight circuitry. From pin 2 is where it basically feeds your backlight circuitry. So let's see what we have on our PP bus first.
So that means both sides of the fuse it must have power.
Yes, definitely. So Peter, I don't know if you can actually bring the camera here so that maybe hey, just take it out. So this is the fuse. You see that has a P sign on it. So that is the fuse. So what we want to do is we want to see what we have on both sides of the fuse. So our black probe is going to be on ground. That is because we are measuring for voltage, and then our red probe is going to be our director. So let's see what we have on one side of the fuse. We have 12.58. Now let's see what we have on the other side of the fuse. We have 12.57. That is good. Now that tells us that our fuse is healthy, so we just need to move past it. Now if we come here, that is now this 2 cap here, that's going to be There's two cap here. That's going to be the backlight output line. This I'm just going to move this aside. Uh, okay, so this. So when we click this, you see what it says, PPV out underscore switch underscore. So now let's click that. So that is going to be our backlight. That's going to be our backlight. Now that we can easily measure here. So that is this. These two caps here. That is our backlight. Can you see it? Now this two here, it's this. This two. So now let's see what we have on our backlight. Okay, so we have 0 volt on our backlight output. Let's just try just to see that we have 0 volt on our backlight output. Now, 0 volt on our backlight output can mean several things. So first thing first, what we want to do first is we now want to work our way, since we have our back. So saying now, because we have 0 volt here, now let's go back. We need to take a step. We need to take a step back and find out how does this rail get generated. Because I mean, we measure here is not present. Now, because it's not present, what do you want to do? You want to go back and find out how is this rail generated. Now, in order to find out how this rail is generated, we can just press this button, the space button, to basically flip the board view to the other side. Another thing we can do, we can easily go to our schematic to find out how it's generated. Or what we can also do here, C9020, is we can just do this and see where it's coming from here. But I think it's easier if you look just here, for example, you see this XW9720. So that so basically that is where a signal passes through from one side to the other side of the board. So so now what we want to do, no, that's not a feedback. This is, so basic, like say for example, if you have something here and then something here, the point where it goes out from the other side. So that is what you have there. So now let us quickly, let's go to our schematic and see how that is supposed to be generated. So we, like I said, to find out where this is coming from, this signal, to find out where this signal is coming from, you want to copy this and then you paste it. Let's just copy, and then paste. So, and then we paste and search. We want to see where that signal is, what is being generated. So now where we have, so we can either just from here, we can just say nest, or we can use this. So we can either come here to just click on nest, or we can just do this. So let's use this one, nest. So it's going to show us everywhere that signal is what is represented on the on your schematic. We go to nest. We want to see where it's been generated. We see it here again. Now let's click another nest. Okay. Now this is what I was showing you guys. See that, like a joint goes out from this side, and then you understand. Okay. Now, so here it says PPV out underscore switch underscore backlight underscore feedback. Now, what you need to know is that this is going to be the feedback line. Now, there's so much you need to understand when it comes to feedback. So your feedback is more like your eyes. Your feedback is more like your eyes. When you're driving a car and your eyes are closed, what are you going to do? You want to stop because you cannot see what is in front of you. Now, this chip here, this is the chip that basically, this is your backlight. This is your backlight chip that generates the LP8550 is what generates your backlight. Now, in order for this pin to for this chip to know when to shut down, when to continue generating backlight or not to, it needs a backlight pin, which is what you have on your A5. Now, this pin is basically, well, this, if you see how this is, if you see what happens. Now, look at, this is where the backlight is generated. Yeah, 40 volt. Now, the 40 volt is generated beyond L9701, which is an inductor. Do you understand? Now, before this, what you get here, so this is going to be a DC to DC boost circuitry. This DC to DC boost circuitry is what takes place here now. Now, why? So because what you get into this chip, It's 12. It's going to be, because it's a MacBook Pro. It's going to be 12.6 volt. That is what will come into this chip. Now a DC to DC boost will take place, and then after this inductor, what you will get is going to become 40 volt. Now there is a diode here. Now this is an inductor, and then you have a diode. Now you see, after the diode, your feedback line gets tied right after the diode to feed back to this component what is being generated. Now, if for example you have a short on this side, yeah, now it will tell you 9701, okay, it's not safe to generate your backlight, your backlight voltage, hence it will shut down. Not just that, if you have a break in line, here, let's say, because this is what is, you're supposed to have a connection between this here, yeah, here up until the pin 5 of LP8550. If, for example, there is a break between this pin and this pin, what is going to happen is this will shut down. Also, there will be no backlight boosting because it cannot see what is producing. I don't know if what I'm trying to say makes sense. That is just a section of the backlight driver. That's just a section of it. You understand? Now you need to know how this works. What are the basics? So here you have switch 0, and then you have your switch 1. Okay. Now, so let's quickly, what you want to see, it says V in. Now V in is the voltage that goes into your backlight driver. So let's see what is our voltage in. Now you see that our voltage in here, what do we have? We have 5 volt. Now we have a PP bus. Now PP bus is what, see here, PP bus is what goes. PP bus is what gets switched on and off, yeah, then eventually get boosted, and then eventually you get your 40 volt after it's been boosted. Now, just on that 40 volt, 40 volt is the max of what the chip is going to generate for this circuitry. However, when you measure your circuitry on your backlight output, if you measure 40 volt, what it tells you is your screen is not, there is no load on your screen. Your screen is not consuming what has been created. Usually that will mean that you have a faulty cable, or sometimes a screen as well. So what will happen is, let's quickly go back to our, now what will happen is, so what will happen, you will find that on your backlight, on your backlight cable, the backlight will be, there will be a break in line on your backlight cable usually. So whenever you measure the maximum voltage in a particular line, so what it tells you is the voltage itself, the backlight voltage, is not being consumed by the screen. Now once the screen consumes part of it, the voltage will drop. It will now reduce. Do you understand? And then obviously that can now change according to how much brightness you have on your screen. I don't know if it makes sense. Now, but right now, if we had 12.6 volt here, it tells us that we are not boosting. If we had 12.6 volt here, it means that we have voltage output, but however, it's not boosted. But in this case, we do not even have voltage here. So what we want to do, because we don't have voltage there, first thing first, we want to see if we have a short there. We want to see if we have a short here. So I'm just going to measure to confirm if I have a short. Obviously, I need to confirm if I have a short, I need to disconnect power from the board, because I cannot measure for a short with power on the board. Now I want to switch my multimeter into continuity mode. Now let's just see if we have a short on that line. Okay, we do not have a short. So now also this connector has been replaced, and then we're not sure why they replaced the connector. So what we want to do is, let's not worry about the connector now. Now let's connect it and then go back to how our PPV output needs to be generated. Now, how do we get this signal to be present? Now let's go back to our schematic. Okay, now we want to now see before, okay, let's see, now let's come here, PB bus underscore switch underscore LCD power. Now we talked about how we want how that is going to work. Now here, this is our fuse. This is our fuse. PP bus goes into our fuse, and then it comes here. We have a voltage divider. Now, the way this is supposed to work, it's so this in order for voltage to go through, so this needs to be lowered, and obviously the LCD backlight enable signal will allow that to happen. So the voltage needs to be lowered. Backlight platform reset L also needs to be present. Now, when that is present, then obviously the voltage, now we can, when this circuitry works fine, then we can have an output here. So what we want to do now is we want to find out if we have an output here at Q9706, because if we don't have an output, we will not be able to power our LCD backlight at a particular level. So now here it says what? 12, we need this 12.6 to be present. Now let's first see if we have this voltage present at Q9706. So how do we do that? We go to our board view, we type Q9706. It's going to be on the other side, but just for the fun of it, let's just show you guys. So it says is what? Q9706. So that's Q9706. So let's see. Now this is Q9706, which is on the other side of the board. So we want to do this. Let's see if we still have our we no longer have our flashing folder. Let's just disconnect and see why that is. We need to make sure our screen is it's properly detected before we worry about backlight. Let's just try that again. We need to make sure that we have screen detection. So I'm going to also remove the speaker because that will give us room. Okay. Okay, I see some kind of liquid in that section. But right now we're not worried about that. First and first, let's get our image on the screen. Do we have image yet? We may have to do multiple repairs on this board. Because so I'm trying to get image on our screen, and so far we do not have image on our screen. We're waiting for the flashing folder. We had it before, but now we don't seem to have a flashing folder. And I'm also very skeptical. The fact that the LCD connector was replaced, I'm not sure why that was. Yeah, I suppose there was liquid in that region, so hence the reason why they had to replace the LCD connector. Still no flashing folder. Now, we may just have to replace it. Let's disconnect it and then reconnect just to be sure. Let's disconnect. Let's try to reconnect it. And another thing to note is if the connector is improperly soldered, that will also cause you not to have backlight. So I'm not sure why the connector was removed in the first place. So we may have to replace the connector altogether because we don't want to work on a partial communication on the screen connector. Let's try to press on the screen connector to see maybe if we'll have contact. Still nothing. There's nothing. Okay. Now let's be sure that the let's just confirm that the machine is starting. So we want to connect our speaker to see if we at least we get a chime sound that tells us that yes, the machine is indeed. Because we don't want to have a machine that say maybe the RAM is not properly. Let's just be sure that the machine itself is starting. It has a brain. See if our speaker is. Yeah, you don't need SSD for it to chime. Another thing we can do is we can use the LED on the drive cable, the LED here, that can tell us the state of it. Let's see if the LED is going to communicate by blinking or just going to remain stable. So that's we want to see what happens here. So if it blinks, if it remains okay, now that tells us that it is communicating. If it had remained just stable without doing that, then you tell that is there's no communication. So yeah, we are actually communicating. So what you want to do is um, let's see what we have in terms of voltage on the screen. Let's see what you have in terms of voltage on the screen. So we wanna check. Let's see. So now we wanna let's check this. Let's see if this is present. Start from there. Voltage mode on. Yeah. So we should get 3 volt on that line. Check on this cap. Check this cap on that inductor. On the cap, what do we get? Okay, on the other side, what do we get? 0 volt. What do you get on this side? 0 volt. What do we get on that side? What do we get? 0 volt. Okay, so we are getting 0 volt. At 0 volt, we will not get anything going on. Okay. Before we worry about backlight, we need to worry about image. So right now we don't have image. Let's put the board in the shell, do a PRAM reset, and yeah, see if we can get at least, because first thing first, we want to get the board to be active before we worry about backlight. Let's quickly take out the board. I'm using a Torx screwdriver, the T6. Did any call for me?
Yeah. Okay.
What was it? What name was it? P. P. You only saw P, that's it. There was no.
We only call once.
Okay. Yeah, let's eliminate this board. Let's see if we have. Another thing, another way we can confirm if we have a brain is to see if we have, um, if the caps lock comes on. That is also going to give us an hint if we have a brain on the board. So we don't want to, because without a brain, you cannot expect to have backlight. You need to have your machine needs to your machine needs to have a brain before you can worry about backlight. So right now, we are not sure if we have a brain, and the reason why. Can I have one screw to hold the listening jack? Let me have screw back, and I'll get it. I'm thinking the big one because most of the screws that will be here will be newer screws. Let's check this one. Okay, yeah, we can use this one. Okay, so what you want to do is, you don't need the battery, but yeah, for the hell of it. So yeah, pretty much is that what you need. So we need a trackpad cable. In order for, I mean, the design of this is such that because we will be needing to use the keyboard, so that's why we are connecting the trackpad cable. Without the trackpad cable, the keyboard is not going to be activated. So without the trackpad cable, the only key that will be activated on the keyboard is going to be the power button. And the reason for that is because the power button is not configured as part of the keyboard. The power button is just by design part of the keyboard, but it's not configured as to be part of the keyboard. Now, the other letters, they function through the trackpad. So if the trackpad is not connected, then the other keys on the keyboard is not gonna is also not gonna function. So that's the reason why we're connecting our trackpad. So we have our trackpad connected. We're just connecting the basic cables that we need. Trackpad cable is connected. The keyboard is connected, and then we need this. This we may or may not need it, but I mean that's just going to give us additional information that we need, which is in terms of we see how the LED behave. But beyond that, I mean, if we get indication on our keyboard, which is in terms of getting a keyboard backlight, then that's enough. We may also not need this. So what we want to do is we want to see if at least we are posting. We want to see if we are posting because there will be no need checking out for. So before you worry about backlights, you need to be sure that you're posting. So let's give it a. Let's wait for it. Aha, and also something I want to mention. So it doesn't seem to probably okay. Uh, I just do this. Something else I want to mention. So from 2011 machines, MacBook. So when you connect the charger, you do not have to, provided with the battery not connected, you do not have to connect. You don't have to press the power button for the machine to start. It will automatically start. We'll go into more details as to why that is in a separate video. Okay. So that it's now one of the so now this is that is happening now. So one thing that okay, there's so much that's happening that obviously beyond the scope of this video. Now there's something that you guys notice. You see that we connect the charger, the machine starts, but there's no indication here. There's no LED. Now this can be the case if this is taking place. If there is SMC, if the SMC is being held down by our keyboard connection. So that would usually be the case if you have liquid on your keyboard. So this is the key that we're expecting to let's see where are you so SMC reset L. So the keyboard can actually reset the SMC. So what we want to do is we want to disconnect the keyboard and see if we will have our LED back. So if we could disconnect the key and then we have our LED back, so that tells us that the keyboard it's faulty. So it's basically resetting our SMC. So you see that now the LED is back. That's because the keyboard is disconnected. So the keyboard is doing the reset. It's basically resetting our SMC, it's keeping our SMC in reset mode. So and that is possible through the power button. So it's more like when you have your power. So what the keyboard is doing is when you're having your power button. Okay, In a separate video, we will talk about switches. There we will talk about, so when I press my power, so there are different reactions that are expected when you press a key, when you press and hold a key, when you double press on the key. So, but usually the two functions that we'll be talking about will be press and hold. So what was happening with the keyboard connected? What was happening was it was assumed that this power key is being pressed and hold. I mean, there's been a press and hold in place. That is why it will reset your SMC, keep your SMC in a reset state, and then because there's no SMC communication, there will be, the LED will be off. I don't know if I'm making sense. So if with this keyboard connected, the keyboard will keep this button pressed down because obviously there probably must have been liquid in this keyboard. So the keyboard will be pressed down. So with this key pressed down, this will reset. Now, there is no issue beyond that point. That is why at least the machine will start. But also when the machine starts, the machine is going to start, the fan is going to work at full speed because the SMC is in reset mode. So that's why when this was connected, the SMC was basically the SMC was in reset mode, and we were not getting any light here. So because we may not be able to use the keyboard in terms of we want to see if our keyboard is our backlight, our caps lock is active, we may want to use this. But another thing we can do, let's see. Even though this is in reset mode, even though it resets that particular line, that doesn't mean that the keys will not work. So it can reset the line, but then your keyboard will still work. You understand? So remember, the line that is being held down is the power line only, the on and off line only. So what we want to do is first and first, let's see our reaction here. Okay, let's see if we let's see what our reaction is here. Is it connected? Okay, let's just do this. Okay, let's see what our reaction is here. You can tell from the LED the state of, okay, that's it. Let's see. Okay, now that is good. Then when the machine starts to boot, there should also be activity here when the machine starts to boot. We do not see any activity LED going on. We don't have any other case, no? No. 2011 also? No. Okay. Okay, fine. Let's connect the chat. Let's connect the keyboard that way and see what happens. Let's see if we can at least get the caps lock on. No, it's fine. Let's just see if we can get the caps lock on. Okay. Just do this. Yeah. See, the fan is running at full speed. See, okay. So we have our caps on. So that tells us that it is posting. See that? I don't know if you guys can see a change in that. See that? Okay, let's try to see if we can get. Let's see if we can try a PRAM reset. Let's hope it's gonna work. Okay, it's off. To do a PRAM reset, so it's Alt Command P and R. So it's this key. With this keys, 2018, especially with these keys being pressed, the machine will wake up from sleep. So let's power the machine. See if maybe we can get to use the keys, even though we don't really trust the keyboard. And yeah, we don't have much option because we don't have an. This is a pretty old machine, and we almost never don't even have a keyboard for this. Let's see, is the machine on? Uh, let's just see if the machine is on. No, it's not on yet. That keyboard, it's that's keyboard. Yeah, we can. But remember, we don't have. It's not keyboard. It's Bluetooth. We can use the other one, the wired one. Yeah, let's have the wired one. Guys, just sit down. Let's also hope the USB ports are working. It's another thing. It's old machines, and it's funny because people usually will want to. So this machine, for example, they want to pay um, a very small fee because they assume it's an old machine, but it takes you the same amount of time to fix a newer machine. Exactly. So let's see, caps lock, caps lock. Nothing here. Okay, so this is what I was talking about when it comes to charging. That is our battery is charging. Mm. Okay, so nothing. Let's check another port. Nothing. This is just gonna waste our time, eh? Okay. It's fine here. Let's just try the screen one more time. This is another thing we can just do is we can just replace the connector and take it from there. What do you think, Peter? Would you just replace the connector because the connector looks funny? We can just put another connector and
And put in your keyboard.
no. I'm talking about the screen connector. So should we just replace it with another one? Just replace it. Because the connector definitely looks funny. So, mm, let's put another connector there. And then, let's see, what time is it? Uh, okay, let's see what you can do between now and 7:30, yeah? Between now and 7:30. Okay. Imagine how much time you're spending on this, and then the owner will tell you it's an old machine. I mean, it's yeah. Okay, at least you guys get to have a glimpse into uh, a bit of your backlight and what how to go over it. Although this is very partial, this is very basic backlight explanation because you have different scenarios of low backlight, and each scenario has a particular and a unique approach to be taken. Can you confirm if this is still on? Okay. So it means this can probably stay for like an hour or two.
I think so because already I think it's nearly going.
I want Dennis. I want half. How?
Yeah,
This one is like what?
but the other it's nearly 35 minutes.
And this one?
The other one was 45 minutes. This is 35.
This is 35.
Yeah.
Time flies, eh? Nah, time really flies. 35 minutes. Ah, okay. So the video is going to be about an hour plus. Okay. And connector is out. We will get another one. Mm. Red. Okay, let's grab another one. We can grab that connector. It's the same thing from 2012 up until 2017 MacBook Air. It's the same thing from 2012 up until 2015 MacBook Pro. You can as well use 2011 connector, but nah, yeah. But let's definitely use a. Let's grab from a 20. Which one is this? That is, it's not ours. So we need a MacBook. Let's see. Can grab one from. So this. Let's just stick from a MacBook Air. This is out. We can use this. So because we want to reuse this, what we want to do is we want to take it from below, not from the top. It's easy that way, so you don't damage it. So take it from the bottom of the board. If you want, you can take it from the top, but then it means you have to reduce your heat. Otherwise, you might damage the connector. So again?
Is there any components behind the?
Yeah, there are, but because I'm moving it, I'm not. It's not stationed, so chances of. But also, you have to know how to move it around. Otherwise, you might yeah, you might components on that side might be affected. But because of the way I'm doing it, I'm not. So it's not stationed. I'm moving it. Cass, let me hold this thing down. Cass, let me hold them down. It's moving, yeah, and it's not supposed to move. Is that hot? Okay, hot air is kind of low. Ideally, it's not supposed to take it that long. The hot air is very low. That's why we had to take so much time to take it out. Okay, thank you. It's out. Now let's replace it. Hmm.
So is it okay immediately when you remove it from the toner board and replace it to the board, or you have to wait to cool it a little bit?
No, it doesn't matter. Yeah, it's cool enough. So we can replace it right from the top. We can do that, or we can use a soldering iron. We use a soldering iron to finalize the process, but we can just hit it from the top. But now, when you're doing this, you have to make sure that this is far away, not close. Otherwise, it will melt it. So the heat has to be far away. Uh, and this is because you're trying to this is a really quick approach, you know. Otherwise, you can use a soldering iron to do everything. So here we make sure we have enough of sodium, so flux, and that side. Yeah. I want to press down, it's like that. Uh, that. Okay, and that's it. Then you use your soldering iron to finalize the process. Your soldering iron do the remaining work. Remove excess solder if there is any. Okay, now let's try to fine tip that. Okay, good. Another thing you want to make sure that you are so when you are here, you want to make sure you don't have too much of that so it doesn't flow over inside your connector. Otherwise, it becomes difficult for your connector cable to go in. You understand? So we just want to quickly, that is that's not off.
Once the solder goes in,
Yeah, it becomes difficult for the cable. Uh, what's the thinness? That's it. Thinness. No, not that. That's no, no. Let's see if this goes in easy. Okay, it goes in easy, and no overflow of the solder into the connector. Let's just take this out. This- Okay, same jack. Let's see if we at least have image. Let me see if we have image before we can worry about backlight. By now we should have image. Okay, yeah, that's image. Can you see the question folder?
Yeah.
Can you see it?
Yeah, I can, but the camera like
Uh, okay. Uh, just gonna. Okay, you can. Somebody can hold it. Give him the phone. You can't. No, no, just give him the phone to flash it from the back. You can't do both at the same time, bruh. Stop trying to be funny. No, you can hold it. Uh, let's see. Yeah, there's changes. Now we're just waiting for flash and folder. I don't even see a flash and folder from here. Let me see. Can I? Not yet. But maybe because the light is not bright enough. Give me your other light. But it's not flashing folder yet, though. So, mm, yeah, there is a flashing folder, but I don't know if you see it. Do you see it?
yes, yeah.
Okay. Okay. So yeah, now we can now worry about our backlight. So at least now that the okay, it's now. Hey, let's see. And there's something else I noticed about the screen. I don't know. Does it look like the screen misbehaves? Like
I can see the black screen and
yeah, like it tries to.
component.
I shouldn't do that.
I don't think that's going
What I think the best thing to avoid.
to get it back to work.
Yeah, let's get another screen so that we can have accuracy in our work. Otherwise, we'll spend too much time here, and we may just have. Yes, we don't have like yes, we want to have a no backlight, but at least let's know that we have a screen that is working.
Working screen.
Yeah, so that we don't have to struggle, and then because when your screen is not working, you get thrown off and you get inconsistent measurements and values, and you just go on a wild chase, and you never get anywhere. So let's get another screen, and yeah, and then let's get another. We don't have any. Yeah, let's get another screen, and then we can continue the repair. Thank you guys. See you when we get another screen. Okay, so we have a confirmed screen. The screen has been we have a confirmed screen confirmed. So what we have also done before we started the video was to also replace U9701. So the two things we did to fix the issue. So first thing first, we had to replace J9000. Like I said, the board has been to a different workshop, so we kind of had to continue from where they stopped. So we replaced J9000, which is the screen connector, and we also replaced the backlight chip U9701. So before we replaced J9000, we had no voltage at all on our PPV out line. But after we replaced it, we were getting PP bus voltage, and obviously no boosting taking place. So we then had to we check to be sure that we have all of the enabled signals as required. We check to be sure that there's no breaking line on the feedback line, which is pin 5. After that, then we replace U9701, which is the backlight driver. And after that, after we replace the backlight driver, then we have backlights. I'm just going to show you guys that now we have backlight. This is the same board. I'm just going to do this. Uh, put this down. Okay, I'm gonna okay and connect charger. Okay, now it's powering on. Let's just see if we have backlight. Yeah, that is backlight. So let's just wait for a blinking folder. Let's see if we will get a blinking folder. And by the way, the folder indicates that there is no bootable source available on the machine. That's why you will get a folder. So just this is not enough. We need to see something. We need to see an image. So the image that we will see, enough for us will be if we see a flashing folder. A flashing folder will be enough for us. We're just waiting to have a flashing folder, and then we can conclude this to be, yeah, that is a flashing folder, and this is a completed repair. Thank you, guys. So in our next video, so what I intend to do, guys, is I intend to have um, I intend to create a playlist of every year Apple lineups, but I'm going to limit that to the notebooks only, which is the MacBook lines only. So we will be treating. So we will be starting from 2012. Okay, we can as well add 2011, but I mean, uh, this machines no longer come in. I mean, the machines that come in now are 2016, 2017, 2018, 2019, 2020s, and even the M2s are started to come in. But then there are still people that want to fix the 2011 machines, the 2012 machines, 2013, 2014. And these are still very great devices. 2011 devices are great. So what I'm going to do is we shall be going over each and every year Apple releases and some of the common failures that you would experience, and some of the quick fix or some of the fixes that you can use. And also we will also advise people on what device that is still great to buy in terms of from a technician point of view. Yeah, pretty much. And we hope to make so much of these videos, especially for people that are coming up. Yeah, and then they will have a better idea in terms of when they are fixing these devices, or when they are about to fix this device, and they can as well advise their clients. For example, somebody coming in with a MacBook Air 2011, which has a common failure on the PCH, usually will fail on that machine, especially in 2023. For somebody to want to fix a MacBook Air 2011, 13 inches, it's if the PCH has not failed already, it's gonna fail anytime soon. Now, imagine if a person is replacing a battery and a screen on a device like that. A battery on a screen is an expensive repair. I mean, it's a repair that's quite expensive. You will spend almost half of, as a matter of fact, whatever if the battery, the money, what what you spend on purchasing the battery and the screen can actually get you just a couple of bucks added to that, you get your decent machine. So instead of buying a screen and a battery on a machine like that, the client should know, and sometimes the technician himself might not know that it's not an ideal repair. This is not something you should do. Rather advise the client. And the beauty of it is because it's a removable. I mean, it's a removable. The machine has a removable drive. If you're worried about the data, you can just connect an external drive to the machine and move your data out. But spending money on getting a screen and the battery on the machine on the 2011 MacBook Air, especially because the PCH is going to fail in time soon. Now, if this was a 2011 MacBook Pro 13 inches, I might not really be skeptical about you fixing it, because the 2011, the 2012, they are great machines if you take good care of them. 2011, 2012, and the 2012 A1425, which is the first Retina 13 inches that Apple transitioned into. It's a great machine. The A1398, however, is not such a great machine because of U8900 issues, and but then there's a bypass for that. You can yeah, there's a bypass for that for the the failure on the U8900, especially when the dedicated graphics. So there is a bypass for that. And 15 inches 2011 also was yeah, the graphics, the GPU was also a failure. Yeah, so we will be going over some of this defects and how you can go over them. Thank you guys, and this is going to be yeah, this we will now move on to another device. See you guys in the next video. Peace out.